Hello, my wonderful students. Good morning today. How are you and your studies? I hope you are good. Today we are in lesson 7. Our topic is factorization of quadratic expressions. Algebraic fractions 1 as our subtopic. So what is an algebraic fraction? An algebraic fraction is part of a whole. Of course, you know that fractions are numbers which are not whole. They are not up to a whole, so we call them fractions. Numbers that have been hampered with, have been, now set of numbers, we have a fractions, diverse kinds, decimal fractions, proper fractions, improper fractions, mixed fractions, and the likes. But in this case, we are considering algebraic fractions. So an algebraic fraction, like I said, is a fraction, is part of a whole, represented mathematically by a pair of algebraic terms, such as this. Of course, you see here, you see the upper part containing A is what we call the numerator, and the lower part containing B is what we call the denominator. AB is what we call the denominator. And you can see another example here. 8u plus 8v is our numerator in this regards, divided by 6u plus 6v, which is the denominator. So the upper part is called numerator, written above, while the lowest part is called the denominator. Majorly, we shall be reducing and simplifying these algebraic fractions. Let's see example 1. In our example 1, we are asked to reduce ABC divided by A squared BC. Reduce ABC divided by A squared BC to the lowest term, or to its lowest term. Solution. In finding the solution, we tend to factorize this expression, this fraction. How? We check for the common terms. A is common in the numerator, A is present in the numerator, and it's also common in the numerator, even double. We see B here is common, is present in the numerator. We also see B in our denominator. Consequently, we see C in our numerator. We also find it in our denominator. So what do? We bring out the common factors. A, B, C are all contained in both numerator and denominator. We bring it, factor it out, and leaving one there. Such that if we say 1 multiplied by ABC, we'll still get our ABC. Does not change the value. See there. We now tend to factorize also the denominator by taking one of the A's here, B and C. In doing that, we leave our A there, remaining one A, because the A there, like I said earlier on, is double. That's the reason why you have it this way. Such that ABC can cancel ABC, leaving you with a 1 all over A. That's the reason why you have here. Your answer is 1 divided by A. Hope you are following. Example 2. We have reduce u cube v minus 3u square v square divided by 3u v cube minus u raised to the power of 2 and v raised to the power of 2 to its lowest term. Like we did in example 1, what we need to do, we factorize them separately. We factorize the denominator separately, and we factorize the numerator separately. So you look out for the common terms here. You see u here is 3 of the u's, because we said u raised to the power of 3. You see it there. You bring it out, you see it's common there, and it's also common here. So you bring out u and your v. You leaving v there. You have u square v. I see it minus minus 3u square minus 3u square v square divided by, same thing goes here, u v square, in factoring it out, leaving your 3 there, 3v minus u. You see it? This place is little bit confusing, but if you go through it properly, you will understand it. Then you now multiply by minus, multiply the numerator by a minus, leaving you with such so that you can have, you see our this thing after the factorization, you see you have u minus 3v, then you have 3v minus u. In order to make this thing the same, we multiply by u by a minus. Remember our u square v divided by uv, we drop it here down so that we can be able to do the arithmetic processes. We use v minus to multiply the numerator, so that by the time we have minus times minus here, with this minus here, you have plus 3v. That is the reason why v comes to this front. By the time you have minus times plus here, here with this u, you have a minus. That is the reason why I rearrange it to suit my purpose, so that I can be able to delete 3v minus u and 3v minus u from both numerator and denominator, leaving me with a minus u square divided by u v square, which is what we have here. If you look at it properly, we can still reduce, since u is common in both numerator and denominator, v is also common in both numerator and denominator, we can reduce. U cancel u here, you'll be left with just minus u, and then v cancelling v here, you'll be left with the bottom v, one of the v's there. And that's it to see it. I hope you are following. In case you have difficulty in comprehending it, you can still watch the clip or the video again. So I leave you here with these two exercises. You can play with them. If you have any problem or difficulty, you can drop your questions and your suggestions in the comment section. Thank you. Till I see you in the next class.